Hi friends, this is Engineer Imran Aziz. Welcome to CivTech Simplified. In today's video, we are presenting part 2 of design of structures. Under this part, we will be presenting 25 MCQs questions for your next exam. And these questions hopefully will help civil engineers like you to prepare for the competitive exams, university tests, as well as your job interviews. And remember, the correct answers would be clearly highlighted so that you could review them effectively. So let's get started with today's part. Question number 26. In working stress and limit state method of reinforced cement concrete design, option A, plane section remains plane after bending. Option B, the tensile strength of concrete ignored. Option C, both A and B are correct. Option D, none of the above. So in working stress and limit state method of RCC design, both A and B are correct, like plane sections remain plane after bending and tensile strength of the concrete is ignored. So A and B both are the correct options. Therefore, option C here is the correct answer for this question. Question 27. Important limit states for design of structures are important limit states for design of structures are number A, limit state of collapse. Option B, limit state of serviceability. Option C, both A and B. And option D, none of the above. So C is the correct answer, which is both A and B are correct. Limit state of collapse as well as limit state of serviceability. So C is the correct answer. Question 28. The characteristic strength of concrete is option A, higher than average cube strength. Option B, lower than average cube strength. Option C, same as average cube strength. Option D, higher than 90% of the average cube strength. So the characteristic strength of concrete is option B, lower than average cube strength. B is the correct answer. Question 29. In working stress method, the factor of safety applied to stress in concrete is usually about. What would be the factor of safety in working stress method? Option A, 2, option B, 3, option C, 4, option D, 5. So B is the correct answer. In working stress method, the factor of safety applied to stress in concrete is usually 3. Question number 30. The failure in case of limit state of collapse is defined in terms of. The failure in case of limit state of collapse is defined in terms of option A, failure stress. Option B, failure strain. Option C, failure load. Option D, all of the above. So D is the correct answer. The failure in case of limit state of collapse is defined in terms of failure stress, failure strain, and failure load. So all these are the correct answers. So D here is the correct option. Question 31. In limit state design, the limiting value of depth of neutral axis for Fe250, like mild steel grade of steel, is known as option A, 0.53 into D, option B, 0.48D, option C, 0.45D, option D, 0.43D. So A is the correct answer. 0.53D is the correct answer. In limit state design, the limiting value of depth of neutral axis for Fe250 grade of steel is 0.53D. Question 32. The maximum area of tension reinforcement in beams shall not exceed option A, 0.15%, Option B 1.5%, option C 4%, option D 1%. The maximum area of tension reinforcement in beams shall not exceed 4%. So C is the correct answer. Question 33. Design of RCC simply supported beam carrying uniformly distributed load is based on the resultant of bending moment at design of RCC simply supported beams carrying UDL is based on the resultant bending moment at option A supports, option B midpoint, option C every section, option D quarter span. So B is the correct answer, mid span. In simply supported beam uh, carrying UDL, the design of RCC based on the resultant of bending moment at is done at mid span. Question number 34. An over reinforced beam fails by how the over reinforced beam fails. Option A crushing of concrete, option B yielding of steel, option C crushing of steel, option D none of the above. An over reinforced beam fails by option A crushing of concrete. So A is the correct answer. Question 35. Maximum depth of neutral axis for reinforced concrete beam having Fe415 grade steel is. Where is the maximum neutral axis for reinforced concrete beam? Option A 0.53D, 0.48D, 0.46D, 0.33D. The maximum depth of neutral axis for reinforced concrete beam is 0.48D. B is the correct answer. Question 36. Balanced section is that in which maximum stress in steel and concrete simultaneously attains the option A design stress, option B ultimate stress, option C yield stress, option D breaking stress. So what is the balanced section? Balanced section is that in which maximum stress in steel and concrete simultaneously attains the design stress. So A is the correct answer. Question 37. One of the assumption in limit state of collapse flexure is that the maximum strain in concrete at outermost compression fiber is. So what is the maximum strain in concrete at the outermost compression fiber? Option A 0.002, option B 0.003, option C 0.0035, option D 0.0003. So C is the correct answer, 0.0035. Question 38. Why the design of reinforced concrete over reinforced section is undesirable? Why we don't prefer the over reinforced section? Option A. It consumes more concrete. Option B. It undergoes high strain. Option C. It fails suddenly. Option D. Appearance is not good. So the over reinforced section fails suddenly. That's why it is not desirable. So C is the correct answer. It fails suddenly. Question 39. Under reinforced concrete beam has a option A depth of neutral axis is less than limiting depth of neutral axis. Option B moment of resistance is less than limiting moment of resistance. Option C tensile strain in steel reaches at yield value while maximum compressive strain in concrete is less than its ultimate crushing strain, all of the above. So all these options are correct and D here is the correct option. So under reinforced concrete beam has all these uh, features. Its depth of neutral axis is less than limiting depth of neutral axis. Its moment of resistance is less than the moment of limiting moment of resistance. And tensile strain in steel reaches at yield value while maximum compressive strain in concrete is less than its ultimate crushing strain. So DE here is the correct option. The minimum tension steel in reinforced concrete beam needs to be provided to option A, prevent sudden failure, option B, arrest crack width, option C, control excessive deflection, option D, prevent surface cracks. So minimum tension steel in reinforced concrete beam needs to be provided to option A, prevent sudden failure. So minimum tension steel prevents sudden failures. A is the correct answer. Question 41. And under reinforced sections are option A, undergo larger deflection at failure. Option B, fail suddenly. Option C, capable to carry stress reversal. Option D, less stiffer. So A is the correct answer. The under reinforced sections undergo larger deflections at failure. So A is the correct answer. Question number 42. The limiting moment of resistance of singly reinforced beam of size 200 into 500 mm effective is considered consider M20 and Fe415 material. So the limiting moment of resistance of singly reinforced beam of size 200 into 500 is option A 130 kilonewton per meter, 138 kilonewton per meter. Option B 69 kilonewton per meter. Option C 90 kilonewton meter. Option D 235.48 kilonewton meter. So A is the correct answer 138 kilonewton meter. Question 43. A simply supported beam carrying working live load of 2.5 kilonewton per meter and dead load is 3.5 kilonewton per meter. The design load for limit state of collapse is, what will be the design load? Option A 9 kilonewton per meter, option B 6 kilonewton per meter, option C 7.2 kilonewton per meter, option D 12 kilonewton per meter. So A is the correct answer 9 kilonewton per meter. A singly reinforced beam is of width. Question 44. A singly reinforced beam is of width 200 mm. If the factored moment of resistance is 138 kilonewton per meter, then effective depth of beam is for material M20 and steel 138 kilonewton meter. So option A 400 mm, the effective depth of the beam would be 400 mm. Option B 500 mm, option C 657 mm, option D 456 mm. So B is the correct answer. 500 mm would be the depth of the singly reinforced beam. Question 45. A singly reinforced beam is reinforced with 4 bars of 16 mm diameter. Its dimensions are 250 into 500. It is to be designed as option A under reinforced section, option B over reinforced section, option C balanced section, option D doubly reinforced section. So yes, it's under reinforced section, 4 bars of 16 mm dia for a beam of 250 into 500 mm. The steel is under reinforced. Question 46. A singly reinforced beam having effective depth of 500 mm, then how much width of the beam required to resist factored moment of 149 kilonewton meter? So it will be 200 mm. What should be the width of the beam. Option A is 200, option B is 300, option C is 225, option D is 456. So A is the correct answer, 200 mm. 47. As the percentage of tension steel increases in singly reinforced concrete beam, option A, depth of neutral axis decreases, option B, depth of neutral axis increases, option C, lever arm increases, option D, lever arm decreases. So depth of neutral axis increases as the percentage of tension steel increases. Question 48. An under-reinforced section means option A. Steel is provided at the underside of the beam. Option B. Steel provided is insufficient. Option C. Steel provided on one face only. Option D. Steel will yield first. So D is the correct answer. Steel will yield first. And under reinforced sections means steel will yield first. 49. In a singly reinforced beam, if the permissible stress in concrete reaches earlier than that in the steel, the beam section is called option A, under reinforced section, option B, over reinforced section, option C, economic section, option D, critical section. So if the permissible stress in the concrete reaches earlier than that of steel, then that section will be over reinforced section. So B is the correct answer here. Question 50 and the last question for this video part. In a singly reinforced beam, the effective depth is measured from its compression edge to option A, tensile edge, option B, tensile reinforcement, option C, neutral axis of the beam, option D, longitudinal central axis. So B is the correct answer. In a singly reinforced beam, the effective depth is measured from its compression edge to tensile reinforcement. So B is the correct answer for this question. So thank you for watching this video. Please share these videos with your friends and family and follow us on Facebook, Instagram, as well as TikTok. Press the bell icon to get the video at the earliest and subscribe to CivTech Simplified. Thank you very much and see you in the next video.